My name is AP, and today we are going to be working on the physics engine that we have made right here in JavaScript, pure JavaScript, not anything else. So when I left off, we got ourselves like a ball here, and it's a particle. It has gravity once I click, and once it clicks, it just falls. That's all I got. But what we're going to do is we are going to be making a bouncing ball on the bottom of the screen. Now, I'm not going to do it on the side of the screens yet because... Oh, also, I also made a gravity thing where once you click it, it actually makes it fall. But, no, let me just get this out of the way so you can actually see what I'm talking about. Anyways, so instead of actually hard coding this number, I'll put it in here. So then, because I'm going to use it multiple times, I could just do it right here. So we don't need this mouse down anymore. I'm just going to take that out and delete this. So in the update, which is right here, which just tells position, we're actually going to put it right there. So it's going to do it like as soon as it starts. So we don't have to click. My chair is especially squeaky today. I don't know why. Oh, wait. Okay, I had to close the door again. So, when we left off, we had the acceleration and velocity, and then all that. So, the acceleration, it's fine. Actually, it's not the acceleration, it's the velocity. Because every update, the acceleration gets bigger and bigger until, like, super big that it's going too fast for it to actually do it. So, like, if I could make it wrap around screen, it'll just go on continuously. So we're actually gonna limit the velocity. So it'd be if this dot vel x is greater than 2. Yes, if it's greater than 2. Wait, yeah. Let me do y. If it's greater than 2, then it's actually equal to 2. So it'd be this dot vel y is equal to 2. That's it. So I can do it for x, but since we don't have any forces for x, so, oh crap, too slow. Let me do 5. Because sometimes, yeah, oh crap. Okay, so, doing it like, I don't know the limit it should be. Because if it goes 10, then, oh, it's 10, no, it ain't like, okay, so 10 is every time, so it'll be 10 plus 10, so it'll be 20. Instead of 10, then 20, then 40, then 80, then 160. So we're just going to be max of 10. I'm also going to do x real quick because I need to, because we're also going to add x now, because now it's going to bounce, and we want it to bounce around. So if it's greater than 10, it's equal to 10. But we also need, like, subtract it. But not right now. Actually, yeah, right now. I'll just do else if this dot vel x is less than negative 10, which is the same velocity. This dot vel x equals negative 10. So, now it has a way to limit it so it doesn't go incredibly fast, but it's a good speed for right now. Notice this dot force, we don't need this anymore. We need to just make it to where it's 1, because if we want to add an x force, then we would cancel out the gravity and it'll mess things up. So right now we're just going to do force x, copy, actually I won't copy that, I'll copy this, and then I'll copy that, Control C, Control V. That was stupid of me. I mean, I could just do... See? Fair. Okay. So now I can, I don't know what I'm doing. Okay, there we go. So now we can just change this to y, 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 y. So now we actually got to change it here. Instead of force that, we'll just do force y, and we won't have a 0 there. So just be gravity. Control C. Now, what we want to do is now update is also going to be there. So we're going to do if particle particle.x plus particle.width is greater than or equal to canvas.height. That means we need to stop it or give it an upward force. So we need to do particle dot force y -10. So it just goes upward. And the gravity will just then pull it down again. So it wouldn't stay going up forever. Because no matter what, gravity is always going to be affecting it. So when we do that, it should -10. Okay, so if particle, it's y. I always forget. Canvas height, boom. So now it's going to be bouncing. But as you can see, it's going to be bouncing forever at a force of -10. Now, we could just leave it at that, and that's fine for now, but I'm going to make it to where it's actually relative to where it's actually being dropped to, yeah. So, what that is, it's going to be particle dot velocity y, which means it's going straight down. And so we want to reverse that, but we don't want to actually reverse that because then it would, if we didn't reverse that, then it would just go below the canvas width. It'll mess things up. But if we do that negative, then it'll go upward. But then we want to subtract it by a few. So be particle divided by 0. And it has to be a very small amount, like 0.5. Yeah. So force y, and it goes shoot upwards. Is it supposed to be plus? Nope. Okay, so it's not wanting to actually, okay, force y, negative particle velocity, which means it's going to go straight down, minus particle. Should it be plus? I wonder how that works. Okay, plus half it. So, okay, that still doesn't work. Okay, let's see if negative particle velocity works. Okay, so that works, but it just stands there. And then the plus. That's why. So when it goes negative, it's still below the canvas height, but it is going up and down very rapidly. I don't want to zoom in on it, and I don't think it's enough of a difference for us humans to see. So I'm just gonna make it to where it's particle dot vel y is greater than 0. I think it's greater than 0. Yeah. And greater than 0, then go back up. So then it would actually say it'll be okay, and then it'll be negative. Okay, now it's just sinking. Okay, so particle dot velocity is greater than 0. Then what this does is acceleration. So that's the acceleration. Then, because then it's gonna be let's try it now. So it'd be net minus particle dot vel y divided by 1.05. And then that should bounce. Yes, it actually looks like it's bouncing off this, but it's not really. So it actually is abiding somewhere. It's going to go to a stop soon, but I'm just going to make it a bit higher, wherever the particle is. Here it is. 200, so you can actually see it better. So, oh crap, not X. Just do this. Yeah. So, be 100. Down straight up. Boom. Huh? Because I reduced it such a small amount. Maybe we don't need to reduce Y. Because then it will actually get reduced. See, okay, so it is going to get reduced. And now it's just lowering. Anyways, so with that bouncing, we might want to add X to it now. How much time we got? Okay, we only were recording for 10 minutes. Let's go to a bit 15. Let's just see bouncing off the walls for now. Maybe it uses the same thing like that. So Control C. That's for the right wall. So X is canvas width and X is greater than 0. So it doesn't get stuck there, I guess. I don't know. So width, and so it would actually reverse it. And then subtract it. And it's force X this time. So now I'm going to make it to where we click document dot add event listener. And that's just going to be mouse down function. So the function would be force X 0.1. So that would actually just make it move. So now it's going to be bouncing. So once we click mouse down function, force X. It's particle. Particle dot force X. So now, okay, oh crap, oh, whoa, whoa. Okay, so I mean, it is working. It is bouncing off, but it's not what I wanted. Maybe it's plus this time. It's probably just go, yeah, I knew it. So it is minus. Okay. And also, now we need to actually reduce this to a smaller amount because we know that's too fast. Let's try 1. I know it's just going to be very slow, but we can try it. So now it's going to go bouncing, 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 and then it's going to hit this. It's not going to hit this. Okay, X. Maybe we could just, if it actually does do that, then we could do like -1. Then it just reverses it. So now it's bouncing, and it should just reverse it, right? Okay, now it's reversing. It's coming back, but that doesn't have a bouncing of a wall. So we need to Control C, instead of particle X, it'd be minus is less than or equal to 0. And it is less than 0, that means it's going to the left. It should be +1. That means it should just be a bouncing ball across the things. So what this actually does is it actually kind of puts us in a corner that it's never going to just stop. And when it stops bouncing up and down, it's just going to go through. So I'm going to stop right here for now. We could add some sort of friction, so every time it does that, we're just going to subtract the force X minus amount. Maybe we could do that. Particle dot velocity X minus equals 0.1. But then what that does, it makes it go faster that way. Okay, so minus equals maybe negative particle, not negative particle, maybe just particle dot velocity X -2. So it would be the opposite. So it'd be half the speed it was. See, now if we click this, now it's going at 1, now it's going a bit slower, now it's going a bit slower, and then boom, you hit it, and now it's going that. It actually doesn't look like it's going slower at all. Anyways, that's just a bit of a friction example. You can twinker it between videos, but I'm gonna fix it, or actually just do it. So anyways, I'll see you guys later. Bye.